Hello, AP Physics 1 students! It is time for our next lesson. This is going to be our second lesson in our dynamics unit, and today we are going to be talking about friction, just like I said in our Newton's Laws videos. So, let's go ahead and let's get started. Now, what is friction? When an object is in contact with another surface, the surface exerts a force parallel to itself that opposes the motion of that object. Now, this is why it's sometimes hard to push things across an object, because the friction is going to be stopping you from moving it. And there are two kinds of friction. You have your static friction and you have your kinetic or sliding friction. And your static friction is always going to be greater than your kinetic friction. That's for any given pair of surfaces. So, let's take a look at what static friction is. Static friction is the electrostatic bonds that need to be broken before an object can move. Also known as the force required to break these bonds is called your maximum static friction, denoted as F sub F static max. It's really annoying to write, trust me, but yeah. So an important thing to note about your static friction is that the maximum static friction does not always equal the actual static friction. The force of friction is actually going to equal the force applied to an object until that force reaches the max. So yeah. The max is just what you need to reach in order for that object to move. This is because, let's say you had two objects, or let's say you had an object here and the surface here. You're trying to move the object this way, and the friction force is going to be moving that way. If it was moving this way, at 15 newtons, but your friction force, your maximum friction force, was going to be 20 newtons that way, then it wouldn't be staying still. Your object would actually be moving the opposite direction. So that's why your maximum static friction doesn't always equal your actual static friction. We'll look more into that a bit later. So let's take a look at what our kinetic friction is. Kinetic friction is just friction that resists the motion of an object when it's already moving. So it's going to be, your force of friction is going to be less than the force applied in this case. This is when you actually end up getting to move. And this is always going to be less than your static friction for any given pair of surfaces because your object is able to move. Now let's talk about how friction works. The strength of the friction depends on the nature of the surfaces and the strength of the normal force. And the nature of the surfaces is represented by the coefficient of friction denoted as mu, and it has no units. So for your static friction, it's going to be denoted as mu sub s, and for your kinetic friction, it's going to be denoted as mu sub k. Now, we have some formulas that we need to know in order to calculate the friction. So, if we're talking about our maximum static friction, we have mu sub s times our normal force. So you have this normal force and our coefficient of friction come into play. And then we have our force of kinetic friction is going to equal mu sub k times our normal force. Once again, coefficient of friction and normal force coming into play to determine the force of friction. So let's take a look at an example. Example 1. A crate of mass 20 kilograms is sliding across a floor. The coefficient of kinetic friction is 0.3. Determine the strength of the friction force acting on the crate. So in order to do this, as we do with any problem with force, we are going to draw a free body diagram, and we're going to write what we know. So, we have our free body diagram right here. We have our object, our surface, and we have our force arrows. So we have forces acting on it, such as the force of weight, our normal force. Now remember, force of weight and normal force are the exact same magnitude, just in opposite directions. Or at least, when it's like this. We'll get into that later. But in this case, our force of weight and our normal force are going to be the same, but opposite directions. And then we have our force of friction, and we have a mass of 20 kilograms. So, first things first, we need to find our normal force. So our normal force is the same as force of weight, which is mass times gravity. And if we plug that in, we get normal force equals 20 kilograms times 10 meters per second squared equals 200 newtons, and that is our normal force. And we know that for our sliding friction, it's going to be mu times our normal force. In this case, our mu is 0.3. So if we just plug that in, we get our normal force equals 0.3 times 200, and we get 60 newtons. Easy enough? Alright, we're going to go ahead and move on to our next example. Example 2 is just building off of our last one. Find the acceleration of the crate in the previous example if it is being pulled by a force of 90 newtons. All right. So, now from our last, we're drawing another free body diagram, and it looks pretty much the same as the last one, except now we have the force that's being pulled by. So, force of weight, normal force, friction force, and force pulling. We know that the force pulling it is going to be 90 newtons, and the force of friction is going to be 60 newtons. Now, in order to find the net force, we just need to subtract the smaller force from the bigger force, and we get our net force is going to be 30 newtons. Now, in order to find our acceleration, we just need to plug it into Newton's second law. So force equals mass times acceleration, or since we want to find the acceleration, acceleration equals force over mass. All right, so we're just going to go ahead and plug that in. We're going to plug in our 30 for our force and our 20 kilograms from the last example into our mass, and we get the acceleration is 1.5 meters per second squared. All right. Now let's talk about static friction. So in this example, a crate of mass 100 kilograms rests on the floor. The coefficient of static friction is 0.4. If a force of 250 newtons is applied to the crate, what is the magnitude of the static friction? So we're just going to go ahead, draw our free body diagram, and write what we know. So we have our force of weight, normal force, friction, and force applied. We know that our mass is 100 kilograms, mu sub s is 0.4, and our force applied is going to be 250 newtons. So, first things first, we have to calculate for our normal force so we can figure out what the force of our friction is. So, normal force equals mass times gravity, 100 kilograms times 10 meters per second squared equals 1,000 newtons. That is our normal force. Now, in order to calculate for the force of friction, we're actually calculating in this case for our maximum static friction. And we're just going to plug in our coefficient of static friction and our normal force. So we're going to get 0.4 times 1,000 equals 400 newtons. That is our maximum static friction. Now, we already know what our force that's pulling it is, so here's the thing though. The maximum static friction that we just found is going to be greater than the force that is pulling it, which means the box won't move. Now we're going to go ahead and go back to what I was saying earlier, how the maximum static friction isn't always going to be the same as the static friction that is actually being applied. In this case, let's say our force of friction actually was 400 newtons going that way, and it was being pulled by 250 newtons being that way. Now, because it's static friction, that means the box isn't moving. But if this force right here was 450 newtons, the box wouldn't be staying still. The box would actually be going that way. So, as I was saying earlier, the force of the friction is going to be the same as the force being applied until that force is greater than our friction force. In which case, our solution for this example is going to be our static friction is going to equal 250 newtons. It's going to be equal to the force that is applied to the crate. That way the crate will stay still. Anyways, I hope you guys found this video useful, and I hope you learned a thing or two about friction. Yeah, next lesson I believe is going to be about pulleys, and then we're going to do inclined planes, and then I believe we will be done with our dynamics unit. I hope you guys found this helpful, and until next time, cheers!